this popular. This it's been around forever, right? I remember people that used to write ML models back in the days when they have no compute. Usually when they build a model, it took them like maybe 2 weeks just to run a simple linear regression model back in the days. But now we have data everywhere. So we're going to talk briefly about what big data is. And when you talk about machine learning, you talk about data science, there are mostly two main types of models that people build. We call them supervised and unsupervised models. Then as part of you building these models, there are some data prep that you need to go through when you have situations like what we call like overfitting or underfitting. So one of the things you do with underfitting is feature selection. So we talk briefly about that. We talk briefly about data visualization, which is key when you do exploration. We're going to talk about some other aspects of ML that people don't really talk much about, and that's time series. With all this COVID going around in the world, then the power of time series became clear to people, right? We'll talk briefly on time series, talk about spatial models, talk about natural language processing, talk about computer vision. Then I'll give you some resources that can help you as you go along this journey. And if we have enough time, I will just give you a brief demo on one of my projects that I'm currently working on. So when you talk about data science, it's basically just a field that deals with data. So we say it's an interdisciplinary field about scientific methods and processes that extract insights from data. That's the key word there. You are trying to extract insights from data. And to be successful as a data scientist, you need a couple of skills. You need your mathematical skill because to do a lot of statistics. You need some technology hacking skills. You need to be comfortable with programming. Python, I also advise people to pick up Python if you want to be successful in this field, because Python is very diverse. It does a lot of things besides data science. You also need to understand a particular business, right? You can see I told you that for me, I've been doing this in like 5 different verticals. Each of them is a domain, it's a vertical. So whatever problem you're trying to solve, you need to understand that problem and to be able to apply data to it. So here's an interview, just some cartoon, right? So the guy went for an interview and the interviewer was like, wow, you answered every question perfectly. How did you do that? And the guy was like, well, I met with every candidate you interviewed in the last 5 years and collected the questions and answers and correlated it to the interview parameters. And that's what we do in data science. We use the past to predict the future, right? Then he said, and I built a system that predicts the exact question you're going to ask with 85% precision. That's what we do. We have data about the past, we collect data about the past, and we try to use the data to analyze what we think the future might look like. And the guy was like, wow, that's impressive engineering, but I can't hire you on ethical grounds. Then the guy said, don't worry, I was just field testing my prediction system. So that's what we do. You gather data from the past. I remember I used to tell this story, right? When I was in grad school doing my second master's in data science, we're going to have a test, right? And this is some time series that I told you about. And the test is more or less true or false questions, 35 questions. So there's this guy that we were in class together. The guy took all the past questions from the professor. The guy studied them and he came up with a theory. He said, this professor, he gives you 25 true questions and 10 false answers. He said he's not going to study. He's just going to come to the exam. He's going to mark true from 1 through 35. And he's going to make 25 out of 35. He said that's all he needed to get to the next grade, which is a B or an A, I can't remember. He said he doesn't have time. And he did. And truly, the exam came out. The guy made 25 out of 35. We're all data science students. We weren't confident to apply that to a typical exam, but this guy was. He did it, and his theory was perfect. It's the same thing that we're seeing here in this interview. So what do you need to be successful as a data scientist? Like I said, you need to understand math and statistics. You need to have some domain knowledge. And you need to have some soft skills because you do presentations. I've been in a room where I made some prediction and I'm being questioned by domain knowledge experts. I used to work at Verizon. Verizon is a big telecom giant here in the US. There was a time I made some prediction, and on those predictions, it was about drop calls. And there used to be a theory that says You have higher drop calls, I think during the summer, and they related it to signal to noise ratio, right? But the other was telling a different story. So I had to come before a team of engineers who have been proving this theory around for a while and tell them data doesn't back up what they're saying. Yeah, so I have to convince them. I'm in healthcare right now. I work with a VP of clinical analytics. Every once in a while, she has this theory. When this goes up, this should go up. Okay, fine. Give me data. I usually use data and I come back to her and say, your theory might be right, but my data is not backing up your proposition. So you need to be able to stand up before people and tell them what they think is wrong based on the power of your data. I tell people data science is the new MBA because in MBA, in business schools, you are being taught to make decisions. In data science, you are being taught to make decisions with the power of data. So that's what we do, right? And also you need to pick up some database programming skills. You need to understand SQL, you need to understand SQL, relational databases. You need to understand what we call the NoSQL databases, like Cassandra, like Hadoop. So you need to understand all these things come together for you to be a successful data scientist. And you need to be able, like I said, you need to be able to communicate and you need to be able to do some visualization. So this is a Google trend somewhere around 2012 to 2017. You can always go to trends.google.com and trend this out as well. But here we're trying to just trend out all the terms that are related to data science, things like data science, like machine learning, visualization, artificial intelligence, deep learning. You can see over time, there's a continuous steady increase in all these terminologies, except for data visualization. Data visualization has been around for a while. People call it BI, business intelligence, right? But if you see all this data science, all this machine learning, all this artificial intelligence, deep learning, you can see a steady increase over time when it comes to all these data science terminologies. And there's a high demand for data scientists. Harvard Business Review called it the sexiest job of the 21st century. So how do we get to the current age of machine learning, right? Like I said, people that used to build models like 10, 12 years ago, usually like took them like 2 weeks to build a simple model. So you can see the different evolution that we went through before we now got to the world of data science. In the world of data science, we use data to drive our decisions. And in the world of data science, talk about things around machine learning, around deep learning, and you have data that comes to you at a very large scale. But back in the days, we used to have mathematical models, scientific methods, we used to have some hypotheses, right? And also back in the days, we used to do some logical reasoning. But today, we have the power of data. Data is all around us. And with that data, we have more things to do. This is a typical data science process, right? You have real world, reality. From there, you can collect data. Once you have your data collected, before you even go into doing anything, you need to pre-process that data. This is a typical life cycle for building machine learning models. You just don't get into data science and build model. The first thing is you have your raw data. From your raw data, you do some pre-processing. When you do those pre-processing, hopefully you come up with a clean data. If you have a clean data, you can go straight into building models. Once you build models, you're satisfied with the model. The next thing, you have two choices. It's either you take that model, pass it to business intelligence, push it before some executives, and then you make some decisions. Or you can turn it into the product that can be used in real life. And I'll show you a sample of a product I'm currently working on in building towards the end of this talk. So if you think you don't have a clean data set, you want to do more analysis. And from those analysis, you pass back what you think is not right. As part of your analysis, you look for things like what we call outliers. You look for things like what we call missing values. You look for things like, is my data really following a normal distribution? Those are all statistical terminologies that we bring into the world of data science. That's why we say you need to understand math and statistics to be a successful data scientist. So the next stage, now we talk about big data, right? When people hear big data, what comes to the back of their mind is the size of the data. But big data goes beyond the size of your data. There are four main V's that constitute what we call big data. Number one is your volume, which we're all familiar with, the scale, how big it is. Today we have petabytes of data being thrown at us. If you even be a storage, my laptop I'm using to talk on right now has like a couple of terabytes of storage on it already. So data is coming to us.